Hello guys, this is another lesson of iBuddy Math, and today we'll be covering classifying triangles. Okay, so first of all, you guys will have to know two main formulas, a slope formula and a length formula. This should be a reminder of previous years or previous lessons. So just to remind you guys, when you have a set of coordinates, two sets of coordinates, x1, y1, x2, y2, right? When you have two sets of coordinates, or like, let's just replace these by actual numbers, okay? So this is y2, x2, okay? You plug these numbers directly into the formula to get either the length or the slope. First of all, we'll be covering the scaling triangle. A scaling triangle is when all three sides have different lengths, and you calculate it using the length formula. For now, we will not have, this diagram does not have any specific coordinates to calculate, but let's just write down some labeling. So let's label that B, C, and A. So a scaling triangle means that AC is not equal to AB, and it's also not equal to BC. Okay, the length of these sides. An isosceles triangle is when you have two sides that have the same length, right? In this diagram, AC and BC have the same length, therefore it's isosceles. It could also be AC and BC that have the same length, as long as there's two sides that have the same length in a triangle, means that it is isosceles triangle. Finally, the equilateral triangle is when all sides are the same length. Now, we'll move on to classifying triangles based on their angles, whether they are obtuse, acute, or right triangles. That they're very rare, okay? So a professor would rarely ask you, prove that this is a acute triangle, but it could occur, right? It's part of the curriculum and it is taught, therefore it is fair game on the exam or quiz. But I find them very rare that they appear on a test paper, okay? Mostly it will be right triangles. So both to learning, okay? So acute triangles is when a squared plus b squared is larger than c squared, right? So this is derived from the right triangle theorem, like the Pythagorean theorem. A squared plus b squared equals c squared. If these two legs are larger than so let's call this c squared, okay? If these two legs are larger than this side, then naturally it will form a small angle. Therefore, it is an acute angle, right? So basically, you find the lengths of c squared is the largest length, okay? So the largest side of a triangle. So if the two small sides squared are smaller than the largest side squared, then it is an acute triangle. For a right triangle, you have two ways to prove it. A right triangle obviously is when you have a right angle in a triangle. You can prove this using two ways. Either you can use the Pythagorean theorem, and these values are found using the length formula, or you can say that, let's call that A, B, C. So slope of AB times slope of BC is equal to -1, because that's the perpendicular theorem, okay? If this condition is met, therefore the slopes of these two sides are perpendicular, and if they're perpendicular, then they must form a right angle right there, right? So you can either use the slope theorem, a slope thing here, or the Pythagorean theorem. I would recommend the slope because it's much easier, less work, more elegant, right? Finally, the obtuse angle triangle is when one of the sides one of the angles are larger than 90 degrees. And we can prove this by saying that a squared plus b squared is smaller than c squared, right? And again, it stems from the formula of a squared plus b squared equals c squared. If these two sides are smaller than this big thing here, obviously it's going to form a large obtuse angle in between. So as you can see, this diagram here, the hypotenuse is so big and these two legs are so small that it forms a big angle to enclose the triangle, right? Logically, that makes sense. So let's do some practice problems. Let's do a typing error. So the vertices of a triangle ABC are A 1 2, B 7 4, and C 4 9. Using analytical geometry, determine whether this triangle is scalene, isosceles, or equilateral. So let's just sketch out the triangle first. A 1 2 is right here. B 7 4 is around here. And C 4 9 is around here. So let's draw it down. And to determine if it's scalene, isosceles, or equilateral, we have to determine if the length of the three sides are either not equal to each other, two of the sides are equal to each other, or all three sides are equal to each other. And we can do this using, obviously, the length formula. So first of all, let's just find the length of AC. Length of AC will be y1 minus AB first. Sorry, you can do anything first, but I like to do AB first. 4 minus 2 squared plus 7 minus 1 squared. Right, adhering to the formula. I would just plug it to my calculator because obviously this is not an important step. But your teachers would expect you to show all your work. Okay. That is your first length of AB. Now we're going to find the length of AC. Same exact formula, right? Okay. That gives you root of 58. Now you're going to find length of BC. BC is going to be 9 minus 4 squared plus 4 minus 7 squared, which will output root of 34. And we can see that these lengths are not equal. Therefore, because the length of BC is not equal to the length of AC, and it's also not equal to the length of AB, therefore the triangle ABC is scalene. Okay. Now, next question. The vertices of triangle PQR. When I download this as a PDF, it sort of gets like weirded up. Okay, so the triangle PQR has vertices P -2 1, Q 4 5, and R 6 -1. Using the distance formula and Pythagorean theorem, determine whether the triangle is acute, right, or obtuse. Right. So obviously we have to, in order to use the Pythagorean theorem, you first have to obviously find the length of all three sides first. Like, again, the sketching is optional, but I like to sketch it out because it helps me visualize the triangle, and also for harder questions, I feel like a diagram would help for like the more advanced questions, and it gets me into the habit of, drawing a diagram, right? And it's, I find it quite fun, I guess. Okay. Once you've drawn the diagram, let's find the lengths. Length of BQ first. So PQ is going to be same formula. This unit gets really repetitive. Okay, you plug that into calculator. 2 root 13. Length of PR. Right? Go straight into my calculator. If you're doing the IB program, then I suggest you should practice not using calculator, but you know, I'm trying to go through the lesson very concisely, so I would use a calculator. Okay, QR. Okay. To get you 2 root 10, the largest side here is 2 root 17, right? That's your c squared. It's going to be 2 root 17. So we're trying to test out if a squared plus b squared is smaller, larger, or equal to c squared. So let's calculate a squared plus b squared first. Is going to be 2 root 13 squared plus 2 root 10 squared, right? Just gonna give you 6, no, actually 92. Then c squared is going to be 2 root 17 squared, which is going to be 92. No, sorry, 68. Yeah. Okay, so we know that a squared plus b squared is larger than c squared. Therefore, it is an acute triangle. Okay, like obviously going back to the theorem here, acute triangle, a squared plus b squared is larger than c squared. Do we meet that requirement? Yes, we do. Therefore, it's acute. Okay, on to our last question. Let's see. The vertices of a triangle ABC are A 0, 4, B -3, -2, and C 3, -2. Show that ABC is an isosceles triangle. Okay. So by isosceles, it means that two of the sides have the same length. So that means that we have to do length formula. First of all, let's find the length of AB. Okay, that would be 36 plus 9, right? Now, so it's going to be 4 here, and that's going to be 45, root 45. Right? And then you want length of AC, which is going to be -2 minus 4. That. It's going to be also 3 root 5. That's going to also be 3 root 5 here. Because like root 45 is 3 root 5. Okay, so length of BC. Okay. You plug it in. The length formula, which gives you 6. So we proved it because there's only two sides are equal and the other side isn't equal. therefore it's isosceles. Okay, I hope you guys enjoyed this lesson, and yeah, there will be worksheets posted, and if you guys have any questions, please contact us via Discord or email. We're open to any inquiries.